Good morning, sir. So the topic which I am going to explain in the PPT is Buckingham's pi theorem. Under this, I will cover dimensional analysis, fundamental dimensions, and the Buckingham pi's theorem. So first topic is dimensional analysis. So it's the relation between different variables. It is generally used to check the homogeneity of the equation. Homogeneity means that on both the sides of the equation, the dimensions are the same. Like in the given example, we have escape velocity as under root 2gh. So on the left hand side, we have the dimension of v as L by t, length by time. And on the right hand side, we have g equal to L by t square. This is meter per second square, and h equal to L. So L by t square into L. So after solving this, we will check. So on the left hand side, it has L by t, and on the right hand side, it has L by t. So both sides the dimensions are same. So the equation is dimensionally homogeneous. Then our second topic is fundamental dimensions. The three fundamental dimensions are mass, length, and time. So mass is represented by capital M, length by capital L, time by capital T. So the three different kinds of properties are geometric properties, under which covers length, L, diameter, D, and the dimensions like this and properties like this. Then second is the flow property. For property, there are examples like area, volume, head, and then velocity, acceleration, angular velocity, angular acceleration. So for area, the dimensions are L square, volume it's L cube, head it's L, velocity LT minus 1, and like that. In the fluid property, they cover density, force, viscosity, specific weight, discharge. So for density, the dimensions are ml minus 3. Force, it's mlt minus 2. Viscosity, it's for dynamic viscosity, it's ml minus 1 t minus 1. For discharge, it's L cube t minus 1. Now we will see the Buckingham's pi theorem. So Buckingham's pi theorem states that if there are n variables, which includes independent and dependent variables in a physical phenomena, and these variables contain m fundamental dimensions. M fundamental dimensions are m, l, and t. Then the variables are arranged into n minus m dimen, dimensions terms, dimensions, dimensional terms. Each term is called pi term. So this method is used to find dimensional homogeneity, and it has a definite set of variables. So I will explain it using one question. So our question is question 1: the resisting force R of a supersonic plane during flight can be considered as dependent upon the length of the aircraft L, velocity V, air viscosity mu, air density rho, bulk modulus of air K, and it is asked express the functional relationship between these variables and the resisting force. So for proceeding this question, we will first write that R is a function of L, V, mu, rho, and K. Then write it in an equation form: R equal to F of L, V, mu, K, mu, rho, K. Then we will put that function and equate it to 0. So it becomes F of 1 R, L, V, mu, rho, and K. So here we will check the total number of dependent and independent variables. So so n becomes 6, and m is 3 because it contains m, l, and t. So n minus m is 6 minus 3, it's 3. So we have 3 pi terms, and each pi term is equal to m plus 1 variable. So, and where m equal to 3 and also called repeating variable. So when we write pi, it will come, each pi will have 4 terms: the 3 repeating variable and one more, the extra variables which we have left. So in the method of selecting repeated variable, when we the dependent variable should not be selected as repeating variables, and the repeating variable should include these three things and in the correct order. First we choose the geometric properties, like I mentioned it, these are length, diameter, and that. Second are flow properties, these are velocity, area, acceleration. Then fluid property, density, viscosity, and like that. So in this question, the first repeating variable is L. Whenever in a question we have given the geometric variable as L, we will choose L. If we are given D, that is diameter or something like that, we will choose D because D is more prominent than L. So second variable will be V. It will be V only, and the third variable will be rho. Rho is density. We will take rho, always we will take rho, but if in the question it's mentioned that we have laminar flow, yeah, or viscous flow or streamline flow, then we will take mu, that is a viscosity. So now we will write pi1 equal to L A1 V B1 rho C1 R, pi2 as L A2 V power B2 rho C2 mu, pi3 equal to L A3 V B3 rho C3 K. So here now we will write the dimensions of each of the variables given. So R is 4, so it's mlt minus 2. Mu is viscosity, so it's mu uh, ml minus 1 t minus 1. V is velocity, it's lt minus 1. L is L. Rho is ml minus 3. K is ml minus 1 t minus 2. So now equation 2, which was f of 1 bracket R L V mu rho k equal to 0, it becomes f of 1, pi 2, pi 3. It will change according to the question. If we have 4 pi terms, we will write f of 1 equal bracket pi 1, pi 2, pi 3, pi 4 equal to 0, and like that. So each pi term is solved by the principle of dimensional homogeneity. For the first pi term, we will take pi 1 equal to L A1 V1 VB1 rho C1 R. Now on the left hand side, pi 1, it's the power of all the dimensions are 0. So we will write m0 l0 t0, and on the right hand side we will write the dimensions of each of the variable and write the power as given in the pi terms. So now in the next step we will combine all the powers of each dimension on the right hand side, that is m, l, and t. So now on the right hand side we have the power of m as c1 plus m, t minus b1 minus 2, and l as a1 plus b1 minus 3 c1 plus 1. So now we will compare the powers on each of the side. So first comparing the powers of m, it will become 0 equal to c1 plus 1, so c1 becomes minus 1. Then for t, 0 equal to minus b2 minus b1 minus 2, so it will b1 becomes minus 2. Then for L, 0 equal to A1 plus B1 minus 3C1 plus 1. So we will substitute the value of B1 and C1. So A1 becomes minus 2. Now we will write pi1 equal to R upon L square V square rho by, like we will write this after substituting the values of A1, B1 and C1 in the given pi1 we found wrote. Then similarly we will do for the pi2 term. We we change the powers of L V rho as A2 B2 C2, and then we will write the dimension of each term, and then we will combine the powers, and then by equating the powers of each one we will compare. Now we get pi 2 as mu by LV and rho, mu by LV rho. Similarly for pi 3 we will write the powers as A3 B3 and C3 for each term, and then we will combine the powers, and then we will compare the powers. We get pi 3 as K by rho V square. We can check these by writing the powers and confirming it again. So after that we will substitute pi 1, pi 2, pi 3 in equation 3. So f1 of rho by r by l square v square rho, comma u by mu by l v rho, comma k by rho v square equal to 0. So r, now the last step is the final step. So r becomes rho l square v square f1 of mu by l v rho, comma k by rho v square. Thank you.